Welcome you all. Let's move to the fourth unit, dynamics of particles. By the way, what do you mean by particles? Particle is defined as a body whose space and dimensions are considered as negligible, and the mass is concentrated at a center of the point, such like we will be considering. Such kind of thing is called particles. So we shall look into the dynamics of particle, and dynamics is nothing but it's a study, okay, it's a branch of mechanics which deals with the study of forces and their efforts on the moving body. Okay, so dynamics is the study of force and their effect in the moving body. So dynamics of particle we just going to look. When you are seeing the dynamics, actually this dynamics is divided into two, and as well this dynamics of particle is divided into two. One is kinematics, and kinetics. What is the difference between kinematics and kinetics? Kinematics here will be just analyzing the force in the moving body without considering the force that cause motion. Okay, so without considering the force that cause motion, we will be analyzing the moving body. That will be coming under the kinematics. And kinetics considering the force that cause the motion. Okay, so it is on the another hand, it is just without considering, it's considering the force. So here in the kinematics, based upon the types of motion, I can say types of motion, it is actually divided into three. One is rectilinear motion, another one is projectile motion, and curvilinear motion. Okay, so it's a kinematics, and based upon the types of motion, this kinematics of particle being divided into rectilinear motion, projectile motion, and curvilinear motions. So this is what we're going to learn in the kinematics. Actually, this will be giving you the study, or that means the relationship between displacement, velocity, acceleration, and time for the given motion. Okay, so such kind of things we will be considering without considering the force. Okay, relation between the displacement, velocity, acceleration, and the time without considering the force, that comes under the kinematics. So these are the three portions we just going to look into the kinematics of particle. And just moving to the kinetics, it will give the relationship between mass, motion of the body, and the forces acting on it. So here we just looking by having four kind of things, four chapters, just like D'Alembert's principle, okay, this will be the first chapter, and work energy principle, the third one is impulse and momentum principle, last one impact of elastic body, So these are the chapter we are going to discuss in the kinetics. That means considering the force. In this video lecture, we will be just going with the kinematics of particle, okay, kinematics of the particle, and here just we shall know about the rectilinear motion first. Rectilinear motion. What do you mean by rectilinear motion? So rectilinear motion, in the sense, I can say when a particle moves along the straight line, then the motion is called as rectilinear. Straight line in the sense it can be a horizontal or it can be a vertical one. Okay, the motion will be vertical or just inclined one, but it will be straight line paths. Okay, it will be a straight line path. Such things will come under the rectilinear motion. Okay, particle moves in a straight line. In a straight line. For the rectilinear motion, I shall give the example. Just a car moving on the straight road, a body projected vertically upward, or a body falling vertically downward, just for an example of rectilinear motion. It's the first one. The second one, projectile motion. Projectile motion. What do you mean by projectile motion? Projectile motion in the sense when a particle is thrown or projected at an angle. Okay, so for that I shall take XY axis so that you will get what exactly I try to say. So from here I just going to throw any of the particle at an angle. At an angle, it is with an angle you can consider alpha. Okay, so if it is thrown, the particle will just moves under the effect of gravity, just like this, and just it will trace us the path called a parabola. Okay, on the vertical plane between A and Y. So this kind of things, this kind of analysis we will be doing in the projectile motion. So what do you mean by projectile motion? Projectile in the sense when a particle is thrown at an angle with an initial velocity, it will be throwing with an initial velocity and moves under the effect of gravity and traces the path called a parabola on the vertical plane. Okay, which is called as a projectile motion. For the projectile motion, I can give an example. A bullet fired from a gun, throwing of cricket ball from one player to another, a stone throwing horizontally from the top of the tower. Right? Let's move to the second one, third one, which is curvilinear motion. Curvilinear motion. So curvilinear motion in the sense, just I can say when a particle moves in a curved path, then we shall call it as curvilinear. Rectilinear, straight line, it's a curved path. Okay, so that's a thing here. Particle moves in a curved path. Curved path. Next, we have to learn about the types of rectilinear motion. Types of rectilinear motion. So here we have namely three rectilinear motions. One is uniform rectilinear motion, uniform rectilinear motion. In short, we call it as U or M. Okay. So in the uniform rectilinear motion, we'll be calling uniform rectilinear motion if the particle moves in a straight line with constant velocity. That's the important thing. Here the velocity will be constant. And B, which is uniformly accelerated accelerated rectilinear motion. In short, we call it as UARM, uniformly accelerated rectilinear motion, or else uniformly accelerated, uniformly decelerated or retarded. Both are the similar meaning. So in short, I can call it as UD or M, or else U or M. Okay. So here, if the particle uniformly accelerated rectilinear motion, in the sense if a particle moves on a straight line with constant acceleration, here the acceleration is a constant one. If the particle moves with constant deceleration or retardation, then we call it as uniformly retarded rectilinear motion. Okay, uniformly decelerated rectilinear motion. And the last one, which is rectilinear motion with varying acceleration. So here, if the particle moves on a straight line and changes its acceleration from instant to instant, and also changes its velocity from instant to instant, then this type of motion can be described with a position as a function of time, and it is called as rectilinear motion with varying acceleration. Okay, instant to instant, the acceleration and the velocity will be changing. Fine. So then we must know about the three equation. So it's very important one when you are just looking the problem. Three equation of motion for uniformly accelerated rectilinear motion, or uniformly decelerated rectilinear motion, or uniformly retarded rectilinear motion. Okay, for that there is an equation which is very much important. So which is, when you are finding out the displacement, it is given ut plus 1 by 2 at square. S is the displacement, U is the initial velocity, and T is the time, A is the acceleration. Okay, fine. Then one more thing, in terms of velocity, V is equal to U plus AT. I said U is the initial velocity. V in the sense it's nothing but final velocity. Plus acceleration into time. And again one more relation we have, V square is equal to U square plus 2AS. Final velocity square, which is equal to initial velocity square plus 2 into acceleration into displacement S. By the way, what do you mean by a displacement? Displacement in the sense the change of position of the body in a specified direction. Okay, so which is called as a displacement. Change of position of body in specified direction. It will be in terms of meter, we will be measuring it off. Okay, meter, centimeter, or mm, anything may be. Initial velocity in the sense nothing but it's defined as the rate of change of displacement of the body. Okay, it is measured rate of change of displacement, that we can call it as distance traveled by the particle, distance travel meter divided by the time, distance travel per unit So meter per second, we will be noting it off for the SI unit. What do you mean by acceleration? Acceleration is defined as the rate of change of velocity of the body. So it is meter per second square, rate of change of velocity of the body. So when you are having the problem based on the kinematics, okay, so you must remember these three equations. It will be helping throughout the problem in order to identify the unknown which present in the demanded question. Okay, so I hope you understood about the dynamics of particle, kinematics and kinetics, and what is being in the kinematics. Okay, based upon the three types of motions, we just going to have three kind of study: rectilinear motion, projectile motion and curvilinear motion, and the three equation of motion we have studied. So I hope you understood. Thank you so much.